In this video, I am going to find power series expressions for these three functions: 1 over 1 plus x square, 1 over 3 plus x, and x square over 1 plus x. So let's go ahead and start off with the first one. But before I do that, let me remind you of the geometric series that we have known so far. So it's going to be 1 plus x square plus x cube plus dot dot dot. This is nothing but 1 over 1 minus x. This converges for absolute value of x less than 1. We are going to use this geometric series for all of these functions power series expression. Okay, so let's start off with the first one. 1 over 1 plus x square, 1 over 1 plus x square. That is going to be, I can rewrite it as 1 minus x square, right? Which I could rewrite as 1 plus negative x square plus negative x square whole square plus negative x square whole cube plus dot dot dot. Here the assumption is that absolute value of negative x square is less than 1. That's the radius of convergence, or those are the values of x for which this function is going to converge. So I could rewrite it as 1 over 1 plus x square is equal to 1 minus x square plus x to the power 4. So negative x square whole square is x to the power 4. Then negative x square whole cube is negative x to the power 6 plus dot dot dot. Now this is what the expression looks like, and we could, if we want, we could express it as a general term. If we did that, this is what we are gonna get. Okay, summation n is equal to 0 to infinity negative 1 to the power n x to the power 2n. Now let's go ahead and do the second one, b. So 1 over 3 plus x. This is not exactly in this format, but we can convert it into that. So what I'm going to do, I'm going to look at the denominator and factor out a 3. If I did that, it's going to be 1 plus x over 3. And then I could factor out the 1/3 outside completely to make things simple. So there's going to be 1 over 1 plus x over 3, but plus x over 3, I'm going to write it as negative times negative x over 3. Now we have this structure, 1 over 1 minus x, and of course our assumption is going to be that absolute value of negative x over 3 is going to be less than 1. So if I were to rewrite it, it's going to be 1/3 times 1 plus negative x over 3 plus negative x over 3 whole square plus negative x over 3 whole cube plus dot dot dot. And of course the assumption is that absolute value of negative x over 3 is going to be less than 1. Now I could further simplify it. It's going to be 1 over 3 plus x is going to be equal to 1/3 times 1 minus x over 3 plus x square over 3 square minus x cube over 3 cube plus dot dot dot. And I can go ahead and express it in terms of summation. If I expressed it, this is what I'm going to get. Summation n is equal to 0 to infinity negative 1 to the power n times x to the power n divided by 3 to the power n plus 1. In going from this step to this step, I just multiplied every single term by 1/3. And this is what I get. And then you could rewrite it as a summation. So the last one is going to be this. C is going to be x square over 1 plus x. This is not too hard either. You could factor out the x square. That's going to give you 1 over 1 plus x, but I could rewrite it as 1 over 1 minus x. And now again, there's going to be x squared times 1 plus negative x plus negative x whole square plus negative x whole cube plus dot dot dot. Okay, and of course our assumption here is that absolute value of negative x is less than 1. So it's going to be x squared over 1 plus x is going to be equal to, I'm going to distribute this x square here, so that's going to give me x squared minus x cube plus x to the power 4 minus x to the power 5 plus dot dot dot. Now I could express it in terms of summation notation. So let's say summation n is equal to 0 to infinity negative 1 to the power n times x to the power n plus 2. So this is how you would simplify regular functions such as this using this formula or geometric series formula and convert it into an expression for power series. I hope that this discussion was helpful. Thank you very much.